Hello everyone, my name is Liang Xiao. Recently, I have found an algorithm to solve clique problem with computational time of polynomial order. The clique problem is one of the 21 classic NPC problems. It is of great significance that it can be solved in polynomial time. Because all NP problems can be polynomially reduced to NPC problems, solving the clique problem means that we can find the polynomial algorithms to solve all NP problems, which also means that NP equals P. Now let me briefly introduce the clique problem. A clique is a subset of points in a graph where every 2 points are connected by an edge. The clique problem asks whether there is a clique of size k or larger in the graph. We can easily determine whether these uh, k points form a clique by picking any k points. So this problem belongs to NP. In computational complexity theory, the clique problem is an NP-complete problem in graph theory. It is also called NPC problem. The simplest method is to use brute force to enumerate all subsets of k points in the graph and check whether it is a clique. In a graph with n points, using brute force to find a clique of size k requires at least checking factorial of n over factorial of k times factorial of n minus k subsets of points. It cannot be completed within computational time of polynomial order. I found an algorithm that can determine with high probability whether there is a clique of size k in the graph in polynomial time of the highest order not exceeding n to power 5, and I proved that this probability is greater than or equal to this value. The value of this probability increases with the size of a clique. When the size of a clique is 5, the probability is already higher than 99.97%. Now I'm going to show some results for clique problems using my algorithm. This shows the computational time to find a clique of size 8 in a size of graph from 60 to 300. This figure shows that the computational time increases. And I also calculated the ratio of time used for different kinds of size of graph. We can see that when the graph size ratio is 80 and 60, the ratio of the computational time for these two is 3.72, and it decreases to 2.54 for graph size of 180. And to finally to size of the graph is 160 to 140. The ratio of the computational time is 1.4. And there is another figure, other table showing this ratio. From these results, we can see that computational time does not grow exponentially with the size of the graph. Because if it does, the time ratio will be a constant if the size of the graph increases by the same amount. It shows that the computational time increases with graph size in a polynomial order. This is also consistent to my theoretical proof. Okay, these two, I also attach a few figures showing that finding clique, the results of clique in some graph. Like this one, I found a clique of size 7 in the graph, and this I found a size of clique of size 6 in the graph. The three-set problem, the independent set problem, and the minimum vertex cover problem can also be polynomially reduced to the clique problem. I have also obtained polynomial algorithms for solving these problems. If you are interested in these polynomial algorithms for solving these problems, you can contact me. My contact information is shown here. Thank you, everyone.